there.
Why?
Well, I'm writing tests and assignments. And
Oh, I just wrote 2 twice.
busy dude.
Crazy world, huh? Smells.
So let me explain it first. So I'm going to kind of just throw a graph in the middle. You can put it like below. But e to the x, the graph of it looks like that, right? So the y values on this, I want to draw a little better. Hold on. So the y values on this graph start off, will the y values ever be 0? Will this graph ever hit the x-axis and have a y value 0? It will not. So the y values are very, very small over here. And then they just get progressively bigger as you go. Well, if I were to describe the slope, I would basically say the exact same thing. The slope, it won't ever be 0, right? It's never going to be flat. The slope starts off very, very small and just gets bigger as we go. So if I were to graph the slope of this, the y value right there and the slope right there are the exact same, and the y value and the slope the whole way just match up. So like the y value here is 1. Well, the slope right there happens to also be 1. The y value here would be e to the 4th. The slope is e to the 4th. The y value over here is e to the -2nd or something. The slope would also be e to the -2nd. So it just happens to match up the whole way through. That's the only function that is the derivative of itself. It's e to the x. And the AP test loves that. They put e's all over the AP test. So it just gets into using our rules, remember the definitions. If there's an e in your problem, it is typically the big guy. Not every time, but that's like the first thing I'm going to check. If I see an e, I'm going to check and see if that's the big guy, and it usually is. So if I look at that first one, e is the big guy, and 4x squared is your little guy. So the derivative of e is e. What do you do with the little guy? Leave it alone, and then you multiply by the derivative of the little guy. So that would be your answer for the first one. Let me jump to 3, because 2 and 4 are just a little trickier, I guess. First of all, what is x over 4? What if I rewrite that? It's 1/4 x, right? So it's a lot easier for most people if I say 1/4 x. But because x over 4, you start to think like it's a quotient rule or something, but it's not. Anyway, it's just e to the 1/4 x. So your big guy here is the e. The derivative of e is e. You leave the little guy alone, and then you multiply by the derivative of the little guy. Number 2, I didn't really mean to put this on today's stuff, but I did it, so it's not like impossible. That's a triple chain, or a double chain. So what's the big guy? E, what's the middle? Cos, and then your little would be 4x. There's actually none of these on today's homework, but it's not that bad. So the derivative of e is e. You leave the other 2 parts, the middle and the little, alone. So we're always just kind of rewriting that first chunk. Then I would move on. So what's the derivative of cos? Negative sine. I would leave Mr. Packard alone again. And then finally, Mr. Packard's derivative. For number 4, and I meant to talk about what this is the trig too, I didn't quite get to it yet. But if there's a constant in front of a trig, or an e, or an ln, the constant just drops. So the derivative of 3e to the 5x would be 3e to the 5x times 5. So just to talk through that, the constant drops, stays with it. The derivative of e is e. You leave the little guy alone, and you multiply by the derivative of the little guy. So I meant to do a couple of those yesterday with the trig and just kind of forgot. But if I gave you y equals, 7 cosine of 2x, take the derivative of that. So a constant in front of letters, basically, e, cos, sine, ln, just drops down. It just stays. It does. And I can show you why too. So it's not just like memorizing, but I'll show you why I go through this one. Yeah, so your answer would be negative 7 sine of 2x times 2. Let me show you why the constant drops, because that's probably more likely to remember. Let's say I looked at this like product rule. I was like, okay, the first function is a 7, the second function is cosine of 2x. The product rule would tell me to do the second thing times the derivative of the first thing. What's the derivative of the first thing? 0. Plus the first thing, this is why it drops. That 7 just stays. Times the derivative of the second thing. So what's the derivative of cos? Negative sine, leave the 2x alone, and multiply by 2. And then what happens to all this? It just goes away. So this, what you're basically doing is the 1d2 part of product rule. And so that constant just stays. Same thing here, like that constant would have just stayed there. So this would be your answer. You are not responsible for this, but you should be able to tell that that's the same thing, right? I don't think that's anything difficult. But. Questions on anything yet? So let's do the a to the x. So a is just any constant. So if I have like 10 to the 3x. So this is a different deal than, like a lot of people try to use power rule here. Bring down the power, multiply, and like leave the 10 alone, reducing the power by 1. But if you're using power rule, that's because the power is a constant. It's just a number. It's squared, or 2/3, or -2, or whatever. Now our powers are variable. That's a different story. This is flipped. With the number down here, the variable up here, we're usually it's the other way around. So that the rule for that is you leave, so the derivative of a number to a power is a number to that power. So all I'm doing is kind of the same thing I did with the e's. So the derivative of 10 to the 3x is 10 to the 3x times ln of the number. So times ln of 10, and then times one more thing. What's the one more thing? 3. So it's not up there because it's the chain rule part of it. So just like the derivative of e to the something is e to the something, the derivative of a constant to the something is a constant to the something. But then you got to multiply by the natural log of the constant. And then worry about the chain rule aspect of it also.
Why is it natural log rather than log based?
That's a loaded question. I don't know the answer to that. That's because someone way smarter than me figured out that's how the slope matches up with the journey. Is that a fair enough answer?
Yeah.
Try that one, that throws people off. But pi is just a number, right? Pi works the same way 10 works. It's just a constant. I don't mean to ignore your question. That's like 4 college semesters out of that. I learned that at some point in my life. Yeah.
Why do you do the times the 3 or times like the 2x?
Times the 2, you mean?
No, it's the one before where it's times 3. That one?
Chain rule. So that's the derivative of the little guy. So our big guy here is like the 10, and then the little guy's the 3. Alright?
Yeah.
So here, our big guy is the pi. The way you take the derivative of that would be to leave it. Multiply, or leave the power the same way it was, and then do ln of pi. So that's like me taking the derivative of the big guy. And the little guy is x squared, so I multiply by the derivative of that. This is not super common on the AP test. They love e's and they love ln's. Those are like, that's why I put asterisks there. Those are like everywhere. They don't use these two very often. Yeah, I mean, they could show up, but they're not super popular. let's say y equals 10, I don't know why I keep using 10, but to the cosine of 5x. That's a little tougher. That's two chains, right? With a z. So that's a number to a power. So your big guy is the number here. And the way you take the derivative of that is 10. You leave the number, leave the little guy alone, and you multiply by the natural log of the number. So that is me taking the derivative of the big guy. What's the middle guy here? Cosine. So then I got to go negative sine of 5x, and then I got to go times 5. How many had that? Questions on that rule? Let me do one more. Let's pretend you didn't know this. Use this rule on that problem. You don't know the top rule. I haven't taught you. You haven't seen it. Use this A rule on that problem. E's a number, right? So you would do, the big guy's e, so you leave the e, and then you would do the multiply by the natural log of the number. Well, what's the natural log of e? It's 1. So technically, you don't even need this rule. Like, this rule applies every time. This is just like a special case. But that special case is the one they care about the most, so like we emphasize that's how you remember it. But really, I could get away with just telling you to remember these two rules. And then if it's e's and ln's, we can just simplify it and work with it. But it's easier if we do these. I'm just kind of pointing out. That's why it works that way. All right, let's do ln's. What number am I at? 10? Thank you. So ln of, let's say, 4x to the third. Again, super common. They love ln, they love e. They'll be all over the AP Calc. The derivative of natural log of something is 1 over that thing. So, the big guy's ln, the little guy's 4x to the third. The derivative of ln is 1 over whatever was being ln'd. But there's still the chain rule part, right? So I have to multiply by 12x squared, and then almost all of these, you're going to be able, just because the way like fractions work, you're going to be able to simplify this. So if you put that over 1 and multiply it across, or start canceling, I mean, you can do a couple different ways, I guess, but if I'm doing it step by step, this is now 12x squared over 4x to the third, which is really reference. Natural log of cosine of x squared. Get a little aggressive again, but we're going to do it. If I write a non-cursive L, people will say, what is y equals in 4x to the third? Did I tell you about my friend in college? She's in college. She would introduce herself as natural log. As nerdiest person ever. She also got my friend, her boyfriend, a picture with her face on it. A T-shirt
Right.
with her face on it. I couldn't understand why I couldn't stop laughing. Okay, so your big guy here is what? ln. Your middle is the cos. Your little is the x squared. So the derivative of ln is 1 over the thing that is being ln'd. Then we got to go down the road. So then the derivative of cos is negative sine, leave the x squared, and then times 2x. So this becomes, oh, this is a good one. So the way that they would rewrite this one, and you wouldn't have to do this, but you would have to be able to recognize it, is they would say negative 2x times, any guesses? How would they simplify it? Tan. So again, you don't have to take that step. But on a multiple choice, this answer wouldn't be there. So you'd have to like recognize it as the same. So sine over cosine is tangent, right? So they would just take that extra step and expect you to be able to match up with their answer. Try that. You're still thinking you made it too hard. What do you do with ln and e's? They cancel, right? So doesn't that just say y equals 8? What's the derivative of y equals 8? 0. You could do it the other way. Do you want me to do it? Yeah. So it'd be 1 over e to the 8th times the derivative of e to the 8th. But e to the 8th is just a number. Right? I mean, it's like 2.7 whatever to the 8th power. It's just a bigger number. What's the derivative of that number? 0. So then you get...
There's no x.
Right. Right. Okay. 13?
Yeah.
So let's say y equals, and this is even less common than, I mean, I'm teaching it, I'm not telling you to ignore it. You're going to have to memorize it, that's going to be on our quizzes. But this is like maybe once every 2 or 3 years, this will be an AP test. This is really rarely used. It'll be on yours probably. So let's say y equals log base 3 of x squared. So what's b? The 3, right? So the derivative is 1 over the natural log of 3 times the thing that you're logging. And then what do you have to do at the end? The chain rule part, right? So this would be 1 over natural log of 3 times, you're going to leave the x squared there. That's the derivative of the log base 3 part right there. Then you multiply by what? 2x. And so if you simplify that, you'd have 2 over ln of 3 times x. Do that. I can use cosine side every time. I should probably mix it in. Does it help you remember the other one? So your derivative would be, so your big guy's the log base 8. The derivative of that is 1 over ln of 8 times whatever you were logging. And then I would multiply by the derivative of the cosine of x, which would be negative sine of x. So it would end up on top. So they would probably say negative tan of x over ln of 8 for their answer. How many had that? Like, even if you didn't simplify it to tan, how many got the sine or cosine term? Okay. You see why it's tan? Sine or cosine. One more. Log base e of x. So it'd be 1 over what? Ln of e times x, and then times the derivative of the x, which is just 1, right? So when you just have this, well, what's ln of e? 1. So don't you just have 1 over x? The reason is, what is log base e? It's ln. So again, it's the same idea as this other one. Like, this ln is really a special case of the log base b. It's just the special case that is most frequently used. But you could technically get away with just remembering these two rules. The weird thing is, they ever use those two, they use these two. Just wanted to show you those little ones. Questions for me at all? Alright. This is just more practice on that, and then tomorrow we'll do more kind of combining a bunch of stuff we've done: product rule, chain rule, quotient rule, trig, ease. There's getting to be more and more types of questions that I can ask you. Take advantage of that. I mean, at some point, if you're absent, you have to, like, they're written on the board. I wrote them up there yesterday. You could, like, ask other people. I get what you're saying.
You wrote the yeses up there.
Those were up there yesterday.
Oh, okay.
I mean, I appreciate what you're saying, but at some point, my attitude is like, I'm doing a heck of a lot by just recording it.